Hello everyone. So in this lecture I am going to discuss about the warping stage. What I think that everyone you know what is warping stage. Basically, the warping stage at the interior and edge and corner regions you have to find. First of all, now let us start that what is warping stage. Okay. Mm, Here I have given a diagram on warping stage. Okay. Basically, the surface of the slab, which is subjected to a wide range of temperature during the daily cycle, okay, or you can say also the seasonal cycle, whereas the temperature of the bottom of the slab in direct contact with the subgrade or base remains relatively more constant. This temperature gradient through the slab causes differential expansion or contraction between top and bottom of the slab. Okay. Suppose as an example, during the day, when the top surface, suppose I'm going to elaborately discuss about this diagram. So in the daytime, when the top surface of the slab becomes hotter than the bottom, the top surface expands more than the bottom, as all we know, and hence the slab tends to assume a shape which is convex upward. This one is a convex upward. Okay, if the slab was weightless and unrestrained, it would warp into a shape of part of a spherical surface and there would be small internal stress only. If temperature gradient varied with the depth, that means depth of the slab. Okay, now suppose the weight of this slab and load transfer devices or friction at joint will restrain free warping. Okay, free warping means the actual shape which is taking according to the temperature, that is known as free warping. Okay, so free warping and will tend to bend it back into its original shape, and as a result bending stresses are created in the bottom. Okay, and the compressive stresses would occur at the top of the slab. Okay, so this incident will repeat not only for day. This will remain same for the night, because in night especially we will find that the bottom part of the slab is much more hotter. Why? Because in daytime the upper surface of the pavement is much more hotter rather than the bottom part of the slab. So when it is night, automatically surface of the pavement releases heat, and automatically uh, when the time passed, it is seen that the bottom part of the slab is much more hotter than the upper part of the slab. So when it is warping, it looks like this shape. Okay, so in night, this shape. So basically this incident is happened due to the differential temperature in daily life, or you can say also the seasonal variation. Okay, clear? So now also another part you have to remember, that another part, that is frictional stresses. Do you know what is frictional stresses? Frictional stresses is very easy to understand. Uh, so what is subgrade friction? Basically, changes in mean temperature of a slab will cause the slab to expand or contract. But if the slab is free to move and there is no friction between the slab and the subgrade, then obviously no stresses will create or generated as a result. However, due to frictional stresses between the slab and subgrade, why frictional stresses is generating? Because if you are resisting the slab to take a shape as per the warping stress, then obviously a stress will create it. Okay, and as a result there will be a crack. Okay, and this crack is basically known as or obviously stress will generate, and this stress will known as stress due to subgrade friction, and in a very short term it is known as frictional stress. And basically this frictional stress is denoted as sigma f. If you see the formula, sigma is equal to WLF by 2 into 10 to the power 4. Now Bureau of Public Roads shows that highest value of coefficient of friction was 2.3, and it is obviously for firm subgrade, or you can say that the tough subgrade. Okay, and coefficient of friction for soft subgrade it is found at 1.15. The composition of subgrade was also affected the coefficient of friction. The resistance offered by subgrade is composed of two elements basically. First one is a resistance caused by simple sliding friction, and second one is shearing resistance in the subgrade due to deformation within the soil. I think that also know how shear stress generated. And if you want to compare this that shear stress and this shear stress, we will find the answer. Why I am talking about the shearing resistance in the subgrade which is generating due to deformation within the soil. Okay. And evidently the frictional resistance will vary from a value equal to twice the weight of the slab where large movement takes place to nearly zero when the slab moves very little over the subgrade. Okay. So in a long slab, we can say that in a long slab, the greatest frictional resistance would be at the end of the slab, and the least would be at the center. Okay. Again, I am repeating. For a long slab, we will find the greatest frictional resistance value, which will be at the ends of the slab. Okay, and the least would be at the center. That means I'm talking about the edge and corner. That means at the ends of the slab, and the least would be at the center. That means at interior, where practically no movement takes place, because when a mm, mm, so for this formula we can say that the tensile stresses for this formula, exactly I'm speaking about the formula. The tensile stress due to subgrade resistance may be roughly calculated by equating the total force of subgrade friction from the free end and the center of slab. Okay, and for the better guidance, please for my view, please for the plan of my rigid pavement. Okay, and some examples also been given. Please see those examples for the better guidance. Okay. Now I will discuss about the combination of stresses. Okay. Please note down my word. The conditions are found to be much more critical as a combination. Suppose I am going to talk about the during summer. Okay. Please note down. The critical combinations at interior and edge regions occurs when the slab tends to warp downward. Again, I am repeating. During summer, the critical combinations at interior and edge regions occur when the slab tends to warp downward. Next, the maximum under the summer season, I am talking about the maximum tensile stress is developed at bottom fiber due to loading and also due to warping. Okay. However, the frictional stress is compressive for the for this summer season. So if we now if we are going to find the critical combination of stresses during summer, we are going to get load stress, okay, load stress plus warping stress minus frictional stress, okay, at edge region, and obviously all is for edge region. That means load stress, here it is showing sigma e, that means load stress at edge region. Sigma TE mainly symbolize for temperature stresses at edge region, and sigma F symbolizes for the frictional stress. Okay, so this one is the critical combination of stresses: load stress plus warping stress minus frictional stress for summer, and obviously the midday, because midday is the much more midday. Why we have taken the midday? Because in if you see that we are going to get maximum temperature in the midday, okay, rather than morning or in the evening. Okay, now during winter, if we consider the midday of winter, then obviously, again just take my word as a note, the critical combination of stress at interior and edge region occur at the bottom, okay, bottom fiber, when the slab contracts and slab warps downward during the midday. Here again I am repeating, during winter the critical combination of stress at interior and edge region occur at bottom fiber when the slab contracts and slab warps downward during the midday. That means both will be positive, sigma E plus sigma T. Clear? Now, uh, so if we are going to write the critical stress combination, we will find load stress plus uh, edge temperature stress plus frictional stress. Okay, at obviously again this is for edge region. Since the differential temperature is higher in summer than in winter, the combination of stress in summer is much more critical. If we see, because there will be enough variation in temperature as night and day. Okay, that's why we are saying that the differential temperature is higher in summer than in winter. Okay, so the combination of stress, if we have to take the combination of stress, then we have to go for the summer is much more critical. The summer is much more critical. Okay, now uh, now suppose as an example, if we see the corner stress, because we are not at all bothered for the interior part, because interior part is much more safer side, in safer side, in rather than edge regions and corner regions. So already we have seen the combination of stresses, how it will act in the edge part. So if we see the corner part, we will find that the uh, corner regions there are no frictional stresses. Obviously, the critical combination occurs at the top fiber of slab during midnight. Now, if you see the why we are omitting the frictional part, because if we see the picture of a warping stress, I am showing it. Just if we see the warping part of any slab, okay, for any time, night or morning, you will find that cornered part is much more safer. That's why we are omitting the we are omitting the frictional stress for the corner part. Okay. Yes. Thank you.